Dr. Jin Kang, thank you so much for spending some time with us this afternoon. Start off by telling our listeners a little bit about who you are and how you came to be involved in space in the military.
Yeah, so my name is Jin Kang. I'm basically like sort of one phrase introduction. I'm the space guy at the Naval Academy. So we develop lots of small satellites, and our main goal is to educate our students so that they get trained up on satellite operations, satellite development, so that they could go out and be effective from day one. Sort of my career path, I think I'm a bit of an oddball in that I knew exactly what I wanted from like when I was really young. So it's always been sort of space, go, go, go. So I've been an aerospace major all the way through. And I've taught at a different university, a normal non-military university in the past. And the Naval Academy opportunity came along. And when I got to learn a little bit more about the Naval Academy program, space program, I learned that there's such a lot of things going on. They're very active. They've been launching satellites for a long time. And to me, it was kind of like a candy shop. It was just the things that they had going on at the Naval Academy was great. So I got an opportunity to work at the Naval Academy, and now I'm running that candy shop myself.
I think you're our first person that we've spoken to who actually got involved in aerospace through the military and continues to kind of work for them in that capacity. I don't think we've had anybody else from the military in space.
We've had some retired folks, but yes, you're in a unique slot as far as a career.
I don't think most people think about aerospace and the military. Can you tell our listeners a little bit about how the two overlap?
So I'm actually civilian. I'm not U.S. military. I used to be a Korean citizen, so I was in the Korean Air Force. And I mean, military and space. Well, space in our lives is very integral to everything that we do in our lives. And same thing with military. When you think space, unfortunately, people may think Air Force, but Navy is sort of the #1 customer of space services. So Navy launched the first U.S. satellite, and Navy's been there from day one for space age. And since it's so tightly integrated with everyday military operations, having students the experience to see how the satellites work, how they get developed, all of that is a huge plus for when they go out into the fleet.
Right. I know the Army tried to launch the first satellite in the U.S., I believe, but the Navy probably was successful the first time. My first memories of you, Jen, I'm working at NSF with this guy named John Moore. It's about 2011. He goes, I know this professor at Drexel, and he does these satellites. And John was always about remote sensing, and using it in the classroom. And so I did meet you the first time. One of my favorite all-time photos of me is actually you and Bob Twiggs and me in a picture at the National Science Foundation. Can you share just a little bit about your experience actually being in a Twiggs classroom? And for our people, for our listeners that don't know, Bob Twiggs is the creator of the CubeSat form factor.
Yeah, so I was a grad student at Stanford, and Bob Twiggs, Professor Twiggs, was my advisor. And we were working on small satellites, and what we mean by small satellite is like 15 kilograms, about 18-inch cube type size satellites. So those are sort of the first generation university satellites. And I've been wanting to get into satellite things, and in my mind, satellite's always been sort of a bus-sized, kind of hard to get to, like NASA only type of thing. But with working with Professor Twiggs, I had the opportunity to actually work on student satellites, like get my hands on stuff that's going to go into space. So that was great. And so we're learning class, teaching, taking his courses, things like that. And one day he comes in, and it was a term project. And he brings in like a little plastic cube that was about 10 centimeters by 10 centimeters. He says, if I were to give you this satellite, what can you do with it? Like, what would you fill it with? And how would you make this an effective satellite? And that was sort of a term project. And, we come up with like these crazy ideas about like, oh, we're going to put propulsion in it and things like that. Crazy idea at the time, now all of those have been realized. And what I like to claim personally is that just because I did such a good job on that term project, the CubeSat was born.
You know what? You're like Star Trek, right? Today's science fiction is tomorrow's science. So,
yep.
And if we fast forward 20 years later, I had the benefit of all of the work that you guys laid down early on to help middle school kids start building CubeSats. Now, I want to pivot real quickly. You teach at the Academy, the Naval Academy. How many years does it take your midshipmen to go from here's our idea to fly in space until it flies? Is it 1 4-year period, or do you start a project and then the kids jump on and jump off? How does that work at the Academy?
Yeah, so mostly within their 4-year career, tenure at the Naval Academy, we would like to have them develop and fly. And that is realized in most cases. So one thing that we cannot control is the launch portion.
Yes.
So they get it done in time, but launch happens whenever it happens, and it continues to slip. Right. So what I do is I sort of flip the script so that the students in their sophomore year operate the satellites that we launch first. And by operating the satellite, they get a good idea of how the satellite systems work. They get good feel for what the satellite is supposed to do and how it behaves. And then they take that knowledge and in their junior and senior year, build a satellite. And by the time they graduate in their senior year, we call it capstone design, sort of the right. Senior year, full year design course, curriculum. And that's when they develop their satellite and get it ready for delivery. And then they graduate.
That's outstanding. My next question was going to be, do the young kids follow the older kids? But you just throw the young kids right into the operational phase.
Yeah.
One last question about the midshipmen and their program. Do you have numerous vendors that you work with, and you don't have to tell me which ones, or do you have like this very short list of parts suppliers that you draw from? And the follow-up is, do you build your own printed circuit boards, or do you buy boards on COTS boards?
So all the elements you just mentioned in your question, we've been bouncing around back and forth within the entire range. So we started with sort of wide number of vendors, and by developing relationships with them, meaning we buy the part, we don't know how it works, we talk to them. If they're nice to us, then the relationship develops, and then students, and then you sort of get pigeonholed into the specific hardware because now you know how it works. And since we're cranking out a satellite a year, it's good to sort of go back to the comfort zone. So we started with a wider range, and now we sort of narrowed down to 3 or 4 vendors that are sort of our go-to vendors.
Right. Well, you have confidence, right? If it's hard when you have flight heritage and confidence to deviate from that.
I want to kind of kick this over a little bit towards some of our students who may be listening, who may never even have considered the Naval Academy as a viable it doesn't make any sense in their mind. I want to be an engineer. Why would I go there? Can you explain a little bit more for how maybe what some of the requirements would be, what the Naval Academy would be looking for, or ultimately why it's a good fit for many engineering students versus other schools, for example?
Yeah. So the military aspect is sort of a personal choice and what they desire. So it's a little hard for me to speak to sort of that aspect of it. From the engineer's perspective, the military academy or Naval Academy, service academies are unique in that our entire resource is focused on educating undergraduate students only. So if you are at different universities that concentrate on bringing a lot of funding through research, the focus is on graduate students and doctorate students in getting the research rolling and bringing in more and more money. Sort of that's the focus there. But here, undergrads, the students are it. We exist to provide the education and training for the students. So as an engineer, the students that are in our current program, I mean, they're getting these opportunities to play with like state-of-the-art technology and state-of-the-art equipment, getting full attention of their professors. So as an engineer at undergraduate level, I don't think there's any better opportunities out there than service academies. So in that aspect, I would definitely recommend. I think it's a wonderful program.
I mean, it's prestigious to be selected to attend the academy. What are some of the, if a student was listening and they're thinking, okay, I've never really considered, what are some requirements or what are some characteristics that a student who attends the academy should have if they see that in their prospects? You'd mentioned like commitment maybe might be an individual kind of thing. Besides that, maybe like, are there certain requirements for GPA or for academics or?
Yeah, from what I understand, the sort of the bar for admissions is similar to sort of top university, top colleges in that good grades, things like that. I know that one special application thing that service academies applicants need is a recommendation from their congressional district. So congressman has to sign off or provide a recommendation. And then of course there's a physical aspect as well.
Right.
One thing, sort of once they come over the fence onto my side, once they get accepted, one thing I notice that I think is another unique quality of the Naval Academy is we make sure that we develop our students for their character as well. So there's academics, they have to be good students, but we really emphasize the character development as well. And I think that's, again, another great opportunity for students who are looking for that sort of environment.
My daughter went to an academy, not the Naval Academy, but I could tell you from a parent of a child that went and graduated, academies like superior academic performance, they tend to have kids that were athletes, and not only athletes, but there's also an element of leadership. I know that's very common with applicants in that whatever that child did in high school, they were probably a leader in that area, whether it be their academics, their athletics, or whatever their passion, I'll call it a passion project, but whatever that thing is that makes you really distinctive, you probably were a leader in it if you find yourself in an academy.
And from the commitment aspect, it's the 4 years, right?
Where you
I think it's 5
now.
Is it 5?
I think it's 5.
Can you maybe explain
5 years
what that commitment is for maybe students or parents who are listening who don't understand exactly, what that is?
So I may be misspeaking, so please double check. But when you graduate from the academy, I think you're obligated for 5 years to serve in the Navy. And after 5 years, you can decide to either continue on or something else.
So it's not happening simultaneously then. In other words, you go to school, you get your training, and then your commitment would come after that. So it's not like you're having to do both at the same time. So it comes after. So it's kind of like, but in exchange for that, you get all the benefits that you would normally get for being in the military. Yes.
It's an incredible fraternity. Yes, it is.
All kinds of benefits. And I mean, for parents, think about this. Day one after the graduation, immediately your children will have a job. That's guaranteed.
Well, that's what I'm thinking. I mean, I think even as a parent, even when you met my son, it was one of those things that I personally never considered because I just assumed that it meant, oh, you have to go into the military and that's it. It's just an extra level of training is what that is in a field that you want to go into and the benefits about it. So I think it's an overlooked way to get your training for school. So.
Right. Well, I'm going to pivot back to the small sats because you are what we call a subject matter expert. My question to you is, so let's say there are folks like me, they're teachers and they work with secondary students, high school and middle school. If you had to design the perfect program to help funnel kids into sort of an aerospace type STEM career using the hardware that you're familiar with, how would you do that with the youngest kids? Where would you start age-wise and what would you have them do?
Ooh, wow, okay. So the struggle that I also face at the university level is the fact that you're building something that's going to go into space is the huge attraction. That's the ultimate motivator. Hey, whatever you're working on, we're going to put into space. For earlier levels where you have to have a lot of background knowledge and things like that, also within part of your learning, that may not always be a possible outcome at the end. So that's where the struggle is. You could make it look like satellites, but it's not full satellites. You use a little bit of that sort of the bling there. But there's a whole lot of key concepts that you could teach at all levels, I believe. So just simple thing like coding on Raspberry Pi processors. Just by interacting with those sensors and things like that. Only difference between what you would do with a Raspberry Pi with some sensors with, say, elementary school kids or middle school kids. Difference between that and a full satellite is it's packaged within some expensive shell that could produce power off solar energy. That's like the only difference. We launch Raspberry Pi processors into space all the time, and they work great.
Wait, at the Naval Academy, or just in general that Pis are used in space?
In general, and I am going to be launching the next satellite with Raspberry Pi processor. So
are you kidding?
Naval Academy is also going in that direction, where we're going to go with commercial off-the-shelf components.
That's wild. We are actually, our next hosted payload mission. Have you ever heard of MicroBits, which I think is a simpler form? It's a gateway board for really young coders. It was made in the UK, and it's about half the size of a Pi board. It has a wonderful little dashboard, where you can write the code in sort of a visual editor or the Python script. And of course, you get sensors and you hook them in. Wonderful. I had no idea you were going in that direction, because the cost of a Pi is really low, and children can use the Pis when they're 6-year-olds in preparation for getting them ready.
So it makes it more accessible, is what you're saying.
You're lowering the barriers of entry as far as the resources a child may have, and the complexity. That's very cool.
Yeah, the complexities, I think, is a big thing too. Some of the schools that I've been helping in the past, one thing I noticed is there's a lot of enthusiasm, but the advisors themselves don't have a lot of experience.
Oh, yeah, you're talking to one of them. So,
well, I mean, I consider you an expert as well, but
not in coding though. That's one of your challenges.
That actually is a weakness. I have a group of kids that meet at a community center. I'm taking a 12-year-old to teach the coding class because he is very good at it. Why should I do the job when I've got a kid that's 10 times better than me? Right,
and so if I were to give a student a full FPGA board and say, hey, learn this and program it, it's not going to happen. Whereas in things like Raspberry Pi boards, I know a high school that's launching Raspberry Pi Zero board, tiny one, just like that, as a main processor. And then there's so much support.
Yes.
And there's lots of literature out there that even maybe a teacher who's just interested but doesn't have really a deep background should be able to come up to speed really quickly.
Why weren't they using them before? Then why is this such a novel
idea?
Well,
it's a confluence of accessibility to space. Right when you couldn't get a ride, there was. I think it's just this curve has become steeper and steeper for opportunities, launch providers, miniaturization of electronics. Am I leaving out an important factor there? What do you think, Jen?
No, I think that's exactly it. Before you get like one launch, your entire career, and you would want to make sure that it absolutely works in space.
Right.
So to give you an example, the Raspberry Pi board, if I were to get the same sort of computing power in radiation hardened, sort of like a full satellite, fully reliable type of format, I'm guessing something like $25,000 for that board to have that be like a big satellite expensive stuff. Whereas now these boards are like tens of dollars, and they survive well enough in space. And just like Kevin mentioned, the launch opportunities are becoming a lot more abundant. Like it's a lot more easier to launch your payload. So hey, why not just gain experience, have fun with it, launch, and if it works, great.
Right, so it's less imperative that you focus only on making sure it's successful, because even if something goes wrong, it wasn't such a huge outlay.
Yes,
at that point. That makes sense.
It's funny. It's sort of like contrasting the SLS NASA rocket versus Elon Musk, right? As far as incremental improvements and things like that. This is outstanding. I had no idea about the Pi, and thank you for that advice about the coding. And I think in the last 10 years, 3D printing has also become pretty ubiquitous at very low education levels. Even though we don't fly chassis made out of plastic, the kids are certainly competent at, you know, a lot of us have kids that print 3D chassis to build the emulators for the CubeSats, which I think visually helps them really come up to speed. Do your kids do a lot of, do you follow the standard CAD model, engineering model, flight model for your kids, or do you have a different way that you train them on putting together their missions?
So that's how it's taught in classrooms. But in actual practice, when students are doing their projects, they're totally spoiled with all these 3D printers. They could print whatever they want, whenever they want. So as an engineer, I advocate, doing analysis, just like you're saying, CAD, CAM, and then, sort of move on. But they have the luxury to print, see if it happens. I mean, if it works, if it fails, they just reprint.
They start again.
And I kind of like that approach. It's kind of growing on me in that I think that may be sort of the future, a good way for students to get really excited and just learn.
So it's iterative, right? Are you saying like your CubeSat models, they just 3D print the parts to form fit them? Or are you just speaking about 3D printing in general?
Both. And for 3D printing, so for example, if I needed a secondary structure to support a new board that we designed, they will just go and 3D print, come back, oh, whoops, I missed the whole placement. I'm gonna just go 3D print again, which is not sort of traditional way, but they do have that opportunity.
Yeah, it's very much the what do you call it? The engineering design cycle, right? Iterate, test, change, adapt, and that's outstanding. Let's see. I have 100 questions, but
well, you can get one more because we are, for the sake of time, almost to the end, and so you get one more.
Jen, what do you see as the future for small sats, not just CubeSats? And I'm sorry I didn't ask earlier, but I presume mostly you build 3Us. Is that correct? And what do you see for the future of small sats?
So yeah, we do mostly 1U bus with a little bit of payload. So we do 1.5U because sometimes we have 2 satellites getting ready to go, and it's good that we could put 2 1.5Us together and we get the whole container and we can do whatever we want with it. I am happy that the government and the military and everyone's taking a much more serious stance on CubeSat technology. I think it's a great movement. Before, we were called debris sats, toy sats, things like that. But there's a lot of potential there, and there's a lot of sort of investment and interest going into it. So I think that's a great direction. At the same time, the things that students get trained on, the CubeSats, as they graduate and go into the fleet or out into the industry, now they've seen the thing before. It was a little bit of a step up going from CubeSat to bus-sized multi-billion-dollar satellites. But now industry and government's coming down a little bit in size and cost and sort of quickness of how fast they could develop the satellites, and then our CubeSat technology is coming up. So I see this sort of narrowing of the gap, and I think that's a wonderful thing.
Right. Is it true that no graduating engineer today working on satellites, all of them have had experience with CubeSats? Would you say that's a fair statement, or are we not quite there yet?
I think it's almost there. CubeSat is such a popular, prevalent. Everyone loves it. Everyone uses it. I think it's a great tool myself, and it seems like when you go to conference and walk around talking to people, like, and you're a big part of it too. Like middle school on, everyone's had their hands on it, and yeah, I think it's becoming a sort of like a normal occurrence for all the education institutions.
Thank you.
Well, our final question is always about giving some advice. So as I'm thinking, about our audience, and there are many parents who have, kids maybe even in high school, middle school. So what advice would you have either for our parents or students who are thinking about maybe taking the engineering track, or may have their sights set on doing something as, as prestigious as the Naval Academy? What advice can you give them about hanging in there to be an engineer?
Yeah. So to me, a lot of students come up, sometimes they haven't decided quite what major to take, and they like science and they're wondering about engineering. Sort of one distinguishing feature that I like to highlight is engineers are people who make stuff happen. So we definitely need scientists, we need mathematicians, we need them to come up with all kinds of theory to help us make the world a better place. But it's the engineers who translate all the theories and new ideas into practical things that we could actually use in our everyday lives. So if you like to tinker, if you like to make stuff, and if you like to make stuff happen, I think engineering is definitely a way to go. Regardless of what career choice you make, one thing I want to emphasize is make sure it's something you really like to do. You're going to be spending a lot of nights, a lot of time working on this stuff. So it's got to be something that you really like to do. I consider myself, like my job, I don't consider it working. Only part that I consider working is grading papers, but all the other stuff, like I said, I threw around the word candy shop. I love being an engineer. I love working on satellites, and it's a great thing. And for the parents, aerospace is booming. We're going to have persistent, what's the word they use? A sustained presence on the moon, and everyone's going space, space, space. Anytime I talk to my colleagues at NASA or other places, they're always asking me if they're good talent, because they're just dying for good talent in aerospace engineering. So it's a great career path, and I see it booming, just exploding in next, that choice of word in our field of work, but I see it exploding in the next few years. So I definitely would like you to consider this as one of your career choices.
We really appreciate you giving them that advice, and also for taking some time out today. It was good to see you again.
Yeah, it was good to see you. Thank you.